All right. Well, hello and welcome to the next episode of 3Din30. I'm your host today, Mike Rogerson, product marketing from Velo 3D. Today, we're going to be talking about moving from R&D into production and some of the challenges that are out there for additive manufacturing users. So if you think of this in the context of manufacturing in general, it's very common to go from one production solution in R&D or development and then choose something else when you go into manufacturing. You think like maybe you manually make something in R&D and then you want to obviously scale this up. And this is very common for other technologies, but for additive, this has been a challenge. And for a lot of users, you might start on an R&D platform and think I can just replicate it to other R&D platforms, the same make, the same model. That hasn't always worked. So you try plan B, you try and go from one R&D platform and you try to go something designed for scale. And the translation of your knowledge from one to another, that always doesn't work either, or doesn't always work either. So you kind of get stuck in both situations here. And I think this feeling of getting stuck has been resonating in the industry. So at Velo 3D, we've been working on a solution that enables customers to more seamlessly transition from an R&D platform to something designed for scale, which in our case is the Velo 3D Sapphire solution. So we're going to be talking about that today. We're going to be talking about that solution. And more specifically, we're going to go through Ursa Major's experience with this in the beta testing. And they've had this solution for a while now. So joining me today, and I'll bring on our speakers, is Thomas Pomorski he's the AM manager for Ursa Major. We will also have on the show Maritza Ruiz, PhD, Senior Director of Process Engineering, Velo 3D, and Ryan Menrath, Director of Product Management, Velo 3D. So before we get into the session, let me remind everyone joining us, this is a live show. We love to take your questions, so please feel free to submit questions at any time, or just give us a thumbs up. Let us know how things are going for you. And with no further ado, we'll dive right in. Thomas, can you tell us a little bit about your background and what you're working on today?
Yeah, absolutely. So I work for Ursa Major. We are a propulsion provider. We build solid and liquid rocket engines. And we want to provide those to other companies that are going to integrate them into flight solutions. So, think about kind of like a kit engine. We're building kit rocket engines. And we're focused on right now, I'm really focused on two product lines. So it's our solid rocket motor efforts and an engine that is in development right now called Draper, which is a storable liquid rocket engine for hypersonic applications specifically.
Nice. So definitely getting in the hypersonics race. That seems to be heating up. I'm hearing a lot about that. Pretty exciting stuff. Maritza, could you give us a little bit about your background?
Hi, I'm Maritza. I'm the Senior Director of Process Engineering here at Velo, and I've been part of the R&D team here since 2018. I have a PhD in heat transfer, as you mentioned, and I've used that sort of expertise to help, solve problems that in the process development realm that we've been trying to address. I currently manage the team that's basically in charge of developing new capabilities, so new printing processes, and also developing processes for new materials that we want to put onto our platform. And so a lot of background in the process development space, and hopefully, excited about the developer project and sharing that to all of our customers.
Awesome. Ryan, your turn.
Yeah. Hey, everyone. Ryan Menrath, Director of Product Management. Been with Velo for about 3 years. Been in the additive industry for about 7 years. Always tried to be close to customers. I started my additive journey kind of, crawling through machines, pulling them apart, rebuilding them on the service side, and then tried to find new ways to interact with customers and deliver capabilities. And it's really glad to maintain some of these relationships. In fact, when, Thomas and I met first, I was in the service organization as a technical account manager. And his voice in our relationship, I think, definitely helped carry developer forward. So really excited that he's here to be our launch partner, and really excited that we've made this product today with him.
And Ryan, I've heard you talk about Flow Developer. You kind of brought this into creation to some degree and have a very personal connection with it. Can you talk about that a little bit?
Yeah, I mean, in some ways, this is kind of the first product that I've seen through as a product manager at Velo. Been doing it for about a year, mostly kind of taking over ownership of existing products as we stood up the function within the company. Developer was one of those things that we identified early on as a gap. It's a capability that's out there and that's dearly needed to support our customers. And so early on, we were like, this is something that we really need to bring to the table, and this is something of a no-brainer. So Thomas had some really good ideas. In fact, his depth of knowledge is really what led us to rendering a lot of the product that we've got now. And Maritza's experience in developing our processes is just kind of this putting the right parties together to create something good for all.
No, perfect. And Thomas, you mentioned a couple different product lines. Can you talk about sort of where they are in their evolution or their readiness levels?
Yeah, absolutely. So, yeah, I run our additive manufacturing program. So I mentioned these two product lines specifically because they heavily rely on additive manufacturing, and a lot of the components for both are built on Velo. So, right now, both product lines are kind of medium stage development right now. We've been building the parts, building rocket engines, testing them, iterating. We're going through that cycle. And one of the things that's really challenging for scaling some of the complex geometry that we have in these parts is making sure that when we go to scale, we can buy more printers and take what we've developed on one printer and apply it to all those other printers. So we really like the golden print file approach that Velo has. And we've done a lot of testing on this across some of our most sensitive components, where we can develop it on one system and then scale it to multiple machines, or scale from a smaller system up to a Sapphire XC, which is really important, as the hypersonic market and defense markets continue to pick up. It's going to be really important to be able to scale these really complicated designs that we have effectively, and to have the quality level that we need to be successful.
And you mentioned the golden print file. A little bit of context on that one. Ryan, can you give us what does that mean?
Yeah, I mean, in a nutshell, it is our solution to repeatability, right? Something that isn't necessarily a truth across additive, and you touched on it in an intro, is getting repeatable output, even with the same input. And so the golden print file, and combined with some other value adds within our technology suite, is really designed to make sure that you're getting the same output. So we have this deterministic print file, right? It has all the laser instructions embedded within it that you can port, from tool to tool. And when you produce it, when you go to print it, you actually do get the same output out of it.
And Thomas, real quick, did you start with Velo in the R&D phase?
Yeah, so for some of the components, we started on a different platform, and we ran into some roadblocks on scaling certain designs across multiple machines. And then we also, a lot of these components have really challenging closeouts, especially. You could think of like pressure vessel shaped components. I know that, yeah, you have one here on the screen. So we want to have the ability to use some of the low overhang parameters that Velo has created, but we have this wealth of knowledge on other platforms. So what we want to be able to do is to basically combine the two into the same part. So we've developed a lot of like high throughput parameters, larger layer thicknesses, kind of simplified parameter sets for simple geometry. And then to be able to combine, maybe you have tube sections with low angle closeouts, and now you can have the best of both worlds, where we can take, previous experience we have and combine it with the Velo, call them special secret sauce that they have to make these really difficult geometry. And it really enables some pretty amazing parts, and really makes the cost benefit analysis really favorable.
And so you kind of mentioned that you've got this combining of processes, but then also accessing scale. So are those kind of the two things that are leading you to look for a solution like Flow Developer?
Yeah, exactly. I mean, yeah, I've been using it for roughly 6 months, and the ability to take legacy designs, we know they work, they're qualified, and then now be able to add on other features that we weren't able to add has really been game changing. And using Flow Developer, we've been able to build some of the most advanced parts that I've ever built in my 8 years in additive. And so it's really a huge leap forward in the industry.
And this access to scale, Ryan, you kind of worked with a lot of the beta customers. Is this a unique challenge that is unique to Ursa, or is this sort of, you could say this is fairly universal?
It's fairly universal, and I mean maybe to step back and set the table a little bit. The metal AM market historically has been used in kind of these low volume scenarios, right? And it started to see inroads into existing, casting replacement, machine parts, these segments to a very limited extent, really to solve kind of an array of problems like, supply chain pain, enabling high customization, development style efforts. But it's also opened up kind of this entirely new emerging market space for complex designs that can really only be produced by AM, which is a little bit of what Thomas is referencing. I mean, across the board, across the entire space, but especially in that, that emerging space, that's where there's kind of the largest opportunity for Additive as a whole to elevate itself from kind of this product development technology to something that's, more well-established, trusted production process. But the big problem to solve there is scalability. It's like once you've proven the value of additive on kind of small scale, how do you transition a process and a part you've qualified on one system to something you can kind of repeatably produce across a manufacturing network and build out, your reliable, high quality supply chain. That's been the big topic that really needs to be addressed across the industry. And that's something, we really think that our platform offers a solution for. So, just to tie that into developer now, it's like developer in and of itself is just this tool designed to be put in the hands of, customers like Thomas, who's invested, years, or in some cases, depending on the size of your team or how old you are, like decades into building the pool of process knowledge, right? And it goes without saying that Thomas and other users, designers kind of know their parts and their optimization objectives better than anyone else. And, developer, really what it does is it kind of, I'd like to think that it introduces this on-ramp, right, for Thomas to put that process knowledge into action on the Velo platform and, hand over the controls, so to speak. So, they can make use of our value adders that, support their scale up.
And it sounds like kind of core to that is being able to make that move or that transfer. And so that's essentially where Flow Developer is fitting in. It's enabling that type of process, right?
Yeah, I mean, Thomas really went for broke when we brought him on initially to do the development. It was like, all right, here's a guy who's going to give us the hardest thing right off the bat, and it kind of proved the value early on of developer for him, and what we hope to extend to the rest of the market.
Well, let's dive into that a little bit. So, Thomas, you brought the biggest challenge. Can you talk about that a little bit in your first days with Flow Developer and kind of pushing it to the limit?
Yeah, absolutely. So we were working on some really large, complex parts with small lattice structures, like basically every challenging geometry that you could have in one part. Oh, and we also want to print it extremely fast because we got to mass produce these at scale. So took Flow Developer early on. Combined some legacy knowledge around some parameters that I developed on R&D platform, and then utilized Velo, the overhang parameters, all in the same part, and then built that part successfully on my second attempt. had one small issue, but really, truly amazing. And on that part specifically, we reduced the build time by roughly 50%. Compared to what we can make a similar part. You can't really make the same part because of the low overhang, but basically the same volume of part. We were able to reduce the build time by 50% and able to get these features that significantly increase performance of the component. So right then I was blown away, and then I started looking at a bunch of other components, some really sensitive injector features, geometry features that have a ton of legacy knowledge around process knowledge, and I was able to port all that knowledge over, build these parameter sets, and the first parts that I built, were flowing within 5%. My first attempt. So I mean, it's hard to get that kind of consistency from one machine to the exact same machine, let alone from a different platform to this platform, to have that same transferability is really amazing.
And are there, we kind of mentioned a couple things with regard to the golden print file, but are there specific things on the hardware itself that help you in this?
Yeah, so a couple things. The non-contact recoder, which is unique to Velo, has also helped with enabling process mapping for a really wide range of parameters, because you're not worried about something damaging the recoder blade or stalling the build. So I've been able to experiment a lot with kind of some unique parameter strategies and things like that for these more advanced designs. So it's been really great. And the other, I don't know, unique thing we didn't really hit on here is the ability to scale from the small machine to the large machine using the same print file. So a lot of other platforms, legacy systems, they're different going from a small R&D machine to a big machine, where now everything I develop on that smaller machine, I can transfer over to the bigger machine. And that's been another kind of unique thing that we've been able to take advantage of as well.
Yeah. So I'm just interested in diving into that a little bit more on the process development side. Maritza, you're kind of the expert on the Velo land. So you mentioned the non-contact recoder as a toolkit. Is that something that you feel that, or that you've had experience with in bringing these processes development for Velo as well?
Yeah, we've definitely had a lot of experience developing processes with the non-contact recoder. I think we've leveraged that to develop sort of the capabilities quickly, and also to kind of create more robust processes so that we can kind of explore wider spaces, and develop processes that are unique to our system that really need the kind of the use of the non-contact recoder. So it's definitely been something that we've taken advantage of, and I'm glad now that other people are going to be able to take advantage of that as well.
No, it's perfect. And we've kind of been dancing around Flow Developer a little bit. Let's show people what this looks like. Can you kind of give us an example of some of the capabilities, and I'll bring this on for you?
Sure. I'll give a quick example here. Are you able to see my screen well here?
Yes.
All right. So here's just a quick example of a situation where maybe you want to test out a few different process conditions. I've set up a build here with 4 parts. And so what you'll see is we'll have this new developer in Flow, we'll have this new developer window, and we'll be able to edit the parameter sets there. So in this case, I have a template parameter set that I've provided, and I want to change the core conditions. So if I have an experiment that I want to run, I can copy the experiment that I want to use and paste that in, and very easily generate my experiment. So say here I'm doing something where I want to test different core conditions out. You can also test different layer thicknesses out as well. I think that's one that Thomas has used. You then, can basically your experiment is done. You can also, very easily make replicates of that. In Flow, I'm just Control-C, Control-V, and now I can use that to, create a replicate for the second laser here. So very quickly, I've created this, experiment layout. This is something that we do kind of on an almost daily basis here. I can then prepare for printing. And to save some time, I've already done that, and I'll just share here kind of what the outcome is. Here, very simply, this is an experiment where it's just core, basically, so nothing fancy. But what you see is I now have different processes at different powers for each part, and I can, see the power, and I can see the speeds that I've set that are different. And if I hover over here, and so that's one nice aspect. It's a very easy, quick way to create an experiment. I can also then save a parameter that I've created. So I can export that parameter set to then say share to the company once I've kind of generated a parameter set that I would like. And I can do that here and save that template. And now I have that new recipe there.
And you mentioned the layer thickness is something you can turn a knob on. I think I heard you mention power and scan speed. And like, what are some of the knobs that a process engineer might look to use for this?
There's a variety of different parameters. We have lasers, speed, power, spot size. There's a decent number, and then we also have basically the contour, speed, power, spot size, and all of the more details will be hopefully provided next week on the webinar. But yeah, so we'll be providing a lot of extra training. We have documentation that's pretty thorough and pretty well done. So this is kind of kudos to Ryan for leading the product side, making sure that we really have a product that is easy to use and it's achieves the kind of the goals that our customers need. So
yeah, we'll put a link. We'll put a link in the comments section for anyone who wants to register for that demo. It's kind of like our shameless plug for the webinar next week. But feel free to sign up for that. We'll have if you can make it live, that's great. If you can't make it live, we record all these sessions. So if you're interested in following along and understanding in more detail what this process looks like, we're going to have a great session on that. And so I wanted to dig into one thing that you mentioned that kind of raised a question mark for me. You mentioned spot size. How would an engineer use, or a process engineer use that?
Here, I'll stop sharing my screen here. So for spot size, I think one of the things Thomas mentioned was increasing throughput of your process. And so for the spot size, we've kind of leveraged that to be able to go to higher power processes. Which can then increase throughput of our processes. But you can also use it for things, for surface finish refinement, you could kind of test a variety of things. So it's just something that we're capable, because we're capable of doing that, we can maybe expand on the process window or process range that you're able to actually, develop on your, with your parameters.
Perfect. We got a question here from Matt. We all know Matt at Velo. Anyway, Thomas, you know Matt? Matt Karish?
Yeah.
Okay. So he asks, in your opinion, what do you think is the biggest thing holding back the AM industry from broader adoption for actual production? And does Velo's technology develop and developer help enable adoption?
Yeah. So him and I have talked about this a little bit, so he set me up here. Yeah, so I mean, the hardest part, the hardest part is scale. So like, if you don't have $1 billion to spend on machines, and even if you do have $1 billion, scaling is still hard. I mean, I could cite tons of examples in the industry of challenges that really large successful companies have had scaling AM, and right now the only way to overcome that is with billions of dollars. So in an ideal world, you want to be able to start on a cheap, small, easy to use machine. And then you want to be able to develop your process and qualify your components. And then you really want to Control C, Control V, and multiply the machines to scale up the number of parts that you want to deliver. And in AM, it does not work like that at all. You need a lot of really talented, smart people to basically hand tune every machine. You have some machines that work really well, and one machine that doesn't for some reason, and it's really hard to figure out what's going on. So, I look at this like additive machines need to be just like CNC machines, right? You don't go in there and you set your spindle speed and you're like, is it really spinning at that speed, right? Like we're way past that. And in additive, we're still at that point in most of the AM space. So repeatability, reliability, and then the ability to seamlessly scale. And one thing I didn't mention, also the ability to scale internal capability, but to be able to take those parts and scale externally, outsourcing components. Right now, financial markets are tight, so the cost of money is pretty high. So, also being able to leverage for overflow capacity, the ability to send parts out and get the same parts back is really challenging in the AM landscape right now. So, coupling all those things together, I think that pretty much sums it up.
No, it's perfect. With this scaling issue, you mentioned other platforms have difficulty. Velo 3D is offering this as a solution and one of our differentiators. Let's talk about what makes this platform work for scale. And Ryan, can you step into that just for a little bit at a high level?
Yeah, I mean, I think at a high level, right, we designed the process and our solution to be scalable. I mean, it was part of the core philosophy up front. There are specific features within our our technology that enable that. I mean, a lot of them go back to the ease of our calibrations, the way we qualify the tools in the factory and kind of maintain that qualification record throughout the service life of the tool. One of the things that's really great about Velo is we have this integrated, kind of end-to-end solution, right? So we have very few dependencies, and so we're able to control for a lot. And then, again, with all of that control comes the benefit of some really great output and repeatable output. So it's the automated calibrations. It's our golden print file. It's Assure that lets you kind of continuously inspect and view the quality of your print process. It's kind of all of those things wrapped together.
Nice, perfect. And we kind of mentioned scale. We mentioned being able to combine best of both worlds a little bit here. Thomas, what other experiences have you had with developer? Some of the things we haven't talked about on this session so far.
So yeah, it's been really great to use, and the thing that I like is what Maritza was alluding to is you have so much control with the variable spot size and all the different parameters that you get to do. So I'm like kind of really excited again about additive. I'm like reinvigorated that I can now go and explore a bunch of new things that I might have read academic papers about. And now I can apply those on a system that I can scale that to multiple machines. Some fellow people might cringe, but I actually just swapped powders in one of my machines to a new alloy that we developed, and and it's not recommended, but we have so much knowledge that we've built on other systems, and now I can take this new material and I'm printing parts basically day one, utilizing a lot of the processes that I've already qualified for that material. So it opens up a whole new. But I mean, it opens up opportunities, for especially other similar nickel alloys. Maybe not more exotic materials, but it's pretty, it's now a possibility. And I think as more people get excited about that, and I would assume that other people are going to want to do the same as well.
Yeah, I mean, what Thomas is, it's like striking the chord of just making it easy, right? Making it easy to do what it is that you want to do, to develop your processes, to really again kind of take control and leverage the best of both worlds. And I think that's going to be the big picture takeaway with developer. I mean, it is again just a tool that enables you access to all the rest of what we offer.
No, nice. And I have noticed we're kind of coming up on time. I do want to get some closing thoughts from everybody. So just kind of go around the horn. I think, Maritza, if maybe we can start with you. What are your closing thoughts on your work with Flow Developer so far? And what do you think the key takeaways are for this product?
I'm really excited to allow customers to kind of optimize the processes for their needs. So a lot of what we've been doing is kind of optimizing for a general solution, a general audience. And I think that actually isn't, as customers are getting very specific, very like, specific requirements, it's really good to allow them to, fine tune that last step for their specific product that they want to work on. And so I'm really excited that like you could take this kind of general solution, fine tune it for exactly what you want, and, bring it to production.
Okay, Ryan, we'll go to you.
What am I most excited about with developer? Yeah, I guess I'm most excited to see how it's going to get used. I mean, this is just another step along our path to make sure that customers stay at the center of our roadmap and development efforts. So, part of what I'm hoping for is getting the read on, Thomas and others, what it is that they're going to ask for next, and, how we can fulfill on those needs, because this is really, truly a new space for us. So it does kind of represent that green field for future development. That's the thing that gets me excited as a product manager.
Perfect. And Thomas, we'll let you have the last word.
Yeah, I mean, I've been waiting for this for years. I mean, basically since I knew about Velo. So I'm super pumped that it's getting out there in the marketplace. And I think, people are going to be able to make some pretty amazing parts that really weren't possible even just before this was there, and then be able to scale those, pretty easily. So yeah, I'm really pumped, and I'm glad that I was able to be a part of this and get a jump start on printing parts, because I'm already using it almost every build that I do right now. So
no, it's awesome. Well, and thank you for the audience joining us today. I think we had a record audience on this session for live session. If you want to see a recording of this, we do provide recordings via LinkedIn and YouTube. Speakers, Thomas, Ryan, Maritza, thank you very much for joining today. An amazing session. Lots of great information out there. And again, if you're interested in learning more, we do have a demo next week. We put the link in the chat, so be sure to sign up for that. If you want to learn more about Flow Developer, we will have a demo, and you can have, it's a live session, so you can put in questions that you want to have answered as well. So thank you again, and we'll sign up.